Okay, let's write a short script in MATLAB. First thing is I write function, then I give the name relative error. Now I have the number of terms n. So let me say that n is equal to 10. Okay. Now I'm constantly adding terms, right? So remember that it is 1 over or x to the power n divided by n factorial. So I have the sum value, let's say, or value, because I'm making an approximation, right? Maclaurin series or Taylor series around 0. Approximation, and I say that this is 0. Okay, then I have the do loop. Index is equal to well, of course I have the x value. I forgot the x. Let's say that x is equal to 0.5. Okay, so it is 1 to n. Then I close the loop. Approximation is equal to or let's say here previous approximation, because I need another variable in order to calculate the true error, absolute error, and previous approximation, and that is equal to approximation. Now I have the approximation, and the approximation is equal to plus x to the power index, divided by x to the power index divided by index factorial, or I can use the command for it, factorial index. Now if I highlight the factorial with my mouse and open it, now I have a menu here, right? Evaluate section, help on section. You see something. This is what you should know when you are using MATLAB. So help on selection will open a document for you. How it works. If that function is defined in MATLAB, okay, factorial n is defined. How it works here. There are alternatives: 10 factorial, 22 factorial, and so forth. So you can use this option if you are not sure about the command. Okay, so this is my well, I forgot, because we begin from 0. It's not from 1. Okay. I corrected. That's okay. And now I have the approximation. Now approximation is equal to 0. Previous approximation is equal to approximation. And now let me write true error. Now I will define something. I will define an array. True error array. Okay. And I open a parenthesis. Now in MATLAB, when you define an array, when you want to define an array, you don't need to define its length beforehand. It automatically adjusts it. Okay, so constantly, depending on the number of terms, it constantly memory for that particular array. Of course, the array index cannot begin from 0, or maybe it's better to change it a little bit. Let's say that it is from 1 to n plus 1. That's better. 0 to n is better. So let's begin with the 1. True error. And the true value minus approximation. Right, this is the true value. This is true fractional error. That's okay. And that is approximation divided by true value. I will define the true value at the moment. Multiplied by 100. Now let me define the true value. Now that is exponential of x e to the power x. Now let's see how x is defined in MATLAB. So it is how it is used, right? Y is equal to e to x, x. And here it gives the definition: exponential for each element of array x, or scalar value x, doesn't matter. So e to the power 0 is 1, e to the power 1 is 7,183 on. Now we see how it works. So now I define the true value, I define the true errors, I've defined the true fractional error. And now I want to approximate relative error. That's okay. Now, approximate relative error is equal to previous error, or the current, because we take the absolute value, so it's not the big difference. So approximation minus previous approximation. I take the parenthesis of it. I put it into the parenthesis. Then I will divide it with the approximation. Okay. Now I have the approximate relative error. Of course, I want to check the approximate relative error by means of iterations. So I will have the error index here. Okay. Now I have the approximate relative error. I have the previous approximation and true error, true fractional error. I calculated all the error types. Now up to n terms. So I will see how it will work. Now I want to plot it on the screen. So I say that figure plot. What's the first one? True error. Because I want to see how the error changes within 10 terms. Now let me run it. No problem. Okay, I made a mistake in the file name, so I will save it to my working file, working directory, okay? Sorry. So let's go to our script directory. Ah, yes, it's here. Now the error that I made is there is a space. There shouldn't be any space in the file name. Now it's okay. Yes. So now I run it. It asked me to change the folder. I said that it's okay. Now you see, this is my number of terms. This is the index number. So 1 corresponds to the index with 0. And 2, it goes like this. And I can, the blue line, my true error. For example, for the second term, or the term with the exponential 1, the true error is 01483. And for the second one, it is 3. So maybe it's better to do it like this. Let me close this. And let me define another term, index array. And this index array has a value of index plus 1. And this will have the index. Now I have another array. Now I will have an XY plot. And you will see it clearly. Now let's open the for plot. You see X and Y. So first I define the array for the x-axis, then I define the array for the y-axis. Of course, you may use some options. You may use different color lines and styles. We will see it in time. You can also experience it by yourself. So this is my plot. Now you see I have the figure. So now the zero term is around 0.65 and goes on exponentially as you increase the number of terms. And the true error, let me pick this point and see the value. I see the x value, I see the y value here, and the error is, the absolute value of the error is 0.02, and it goes like this. And it becomes negligibly small. So at an order of 10 to the power minus 11 for the 10th term. Okay. Now I write here a figure. Okay, I just want to show you something about the MATLAB. So let me delete this figure and let me write a series of plot functions. Now this is true error. Now let's look at the true fractional error. And let's see how the MATLAB behaves then. I write the file name wrong. Okay. Now my figure is there. I made a mistake, I think. Okay, so approximation divided by true value. So this is my mistake. I made a mistake in or better, maybe it's right like this: true error divided by okay. So now I have the true fractional error, true error divided by true value. Now let me open my figure because my figure is already there. And as you see, the error decreases from the first step. So for the zero order term, the error is 40%. Then it becomes 9%. Then it is 1.4, and it goes like this. Okay. So this is the way. In fact, as you see, I didn't see the true error distribution. Now I put here a figure. This will open a figure box. And I put a command, two commands here. So one is the clear all. And the other one is the close all. Now the clear all will clear all variables in the memory, because some of the variables associated with the script that I'm using might be already in the memory. And the second thing is close all. This will close all the windows, including the figures, and the figures that are opened will be related with the existing script. Now you see. So this is the error, true error, and this is the fractional error. And now I'll open another one. Let's see the approximate relative. Oh, there's an error. Approximate, sorry, not approximated. So approximate, I write the variable name wrong. So it gives me an error. Maybe it's better to make copy and paste. Okay, so this is the approximated relative error. So you see the threshold decreases as you increase the number of terms which is now. Let's return to our values or our slides back again.